Your computer's frozen, the pointer won't move, and you press the power button, and nothing happens because that button was never connected to the power. So somebody tells you to hold it in for 10 seconds, and that always works. And half of them will tell you it's bad for the machine. And they're right that it works, but holding it in isn't pressing harder. It's the only part of that button that still goes straight to the hardware. So think about what actually has to happen when you press it. The button is two pieces of metal that touch, and the wire from them runs to a small chip that sits there watching a handful of things like this all the time. And when the metal touches, that chip doesn't cut anything off. It sets one bit in a register to say the human pressed the button, and it raises an interrupt at the processor, and then it goes back to watching. That's the entire electrical consequence of pressing the power button on a running computer. And the specification that defines all of it even gives the bit a name. It's called power button status, and it's a single sticky flag in a block of power management registers. So the press doesn't turn anything off. The press writes a message, and something else has to come along and act on it. And the operating system is the thing that comes along and acts on that message, and it can do whatever it likes with it. On Windows, there's a documented setting for exactly this called the power button action, and it takes 4 values. One of them is sleep, one is hibernate, one is shut down, and the first one, value 0, is called do nothing. Microsoft's own description of that value is no action is taken when the power button is pressed. On Linux, it's a line in a configuration file called handle power key. It defaults to power off, and you're allowed to set it to ignore. And on Mac OS, you don't get a dial for it at all, which is why Apple's own written advice when a Mac has stopped answering is to hold the button in for up to 10 seconds. So that's 3 systems and 3 different names, and the same arrangement underneath all of them. Somebody in software is deciding, and doing nothing is on the menu. So now go back to the frozen machine and watch what actually went wrong. The message got written, the bit got set, and the interrupt got raised, and everything on the hardware side of that button worked perfectly. And then the message just sat there because the software that was supposed to come along and act on that message is the software that stopped answering. And that's the whole of the failure right there. The button didn't break and the press wasn't too soft. You handed a note to somebody who's face down on the desk. And you can press it again, and you'll set the same bit again, and it'll sit in exactly the same place as the first one. So a computer that ignores the power button is a computer doing precisely what it was built to do, and that leaves an obvious problem. If software is the only thing listening, and software is the thing that's broken, then who's left? And the people who wrote that specification knew this was coming, because they wrote the answer into the same document. The wording is that when the operating system's handler is no longer able to respond to power button events, there's a backup mechanism, and the mechanism is a stopwatch. Hold the button for more than 4 seconds, and the hardware unconditionally sequences the system to the off state. Unconditionally, nobody gets asked, and nothing gets to object, and the operating system isn't even told, and the chip makers build it exactly as written. Intel's own manuals say that if the power button signal stays active for at least 4 consecutive seconds, the chip transitions the system to soft off no matter what state it was in, and it goes on to say that this happens even if the signal saying the power is good has already gone away. So the 4 seconds aren't draining anything, and there's nothing cooling down in there. 4 seconds is just longer than any press you'd make by accident. And your phone's built the same way, with a different chip holding the stopwatch. On an Android phone, there's a power management chip sitting next to the processor, and the code that configures it sets up 2 timers, one after the other. The first one can be set as long as 10,256 milliseconds, which is about 10¼ seconds of you holding the key down. And when the second timer runs out after that, the documentation says the chip executes the reset sequence, and it lists the kinds it's allowed to run: soft, warm, shutdown, hard. That sentence never mentions the operating system, because by then the operating system is the thing being reset. And Apple went one step further on the iPhone, where the override isn't a hold at all. It's volume up, then volume down, then hold the side button, which is a pattern no app could produce by accident, and one that no app is allowed to catch. So that's what people are frightened of when they tell you not to hold it in. And the thing they're picturing, I think, is the operating system getting damaged, which is basically the one thing that doesn't happen. Modern filing systems keep a journal, which is a small log of what they're about to change, written down before they change it. So after a hard cut, the structure comes back consistent, because the log says which changes finished and which ones didn't. But the kernel's own documentation is blunt about what that journal covers. By default, it only puts the filing system's own bookkeeping through the log and file data blocks it says aren't guaranteed to be in any consistent state after a crash. So the cabinet survives, and the page you are still writing doesn't. That's the bill. And it's the same bill every time. Not the machine and not the system, just whatever hadn't been written down yet. So there's one press left, and it's the first one you ever make. The machine's off, and you press the power button, and this time it just works every time with no software involved anywhere in it. And that's not because being switched off gives the button more authority. It's that when a computer is off, it isn't really off. There's still a trickle of power reaching that one small chip, and it's sitting there awake in the dark watching the button, and there's nobody it could ask. So it closes the circuits itself, and you can prove that's the whole story in about 2 seconds. Pull the plug out of the wall, wait, and press the button. The button does nothing at all. Take the last of the power away from that little chip, and the button you thought was a switch goes back to being 2 pieces of metal touching. So you've never turned a computer off with that button. You've asked and something decided. The only thing that button has ever done by itself is start. Everything you just figured out rests on something deeper, and that's the next video, so start there. Would you rather understand your computer than just use it? Then subscribe, and I'll see you next time, further down the stack.